Alright, welcome to chapter 3-1, inequalities and their graphs. Okay, an inequality is basically the same thing as an equation. The only thing is an equation has an equal sign. An inequality possesses a less than or equal to, greater than or equal to. So these are what they look like. They look like that, okay? So an equation will have x plus 6 is greater than, 5, okay? Quite simple. All right, so rather than a set answer in which x is defined at a specific constant, it will be more of a wide variety of different solutions. It could be this, and this, right? So, for example, in this problem here, x plus 6 being greater than 5, you would solve like regularly, subtract 6 on both sides. X is greater than -1, okay? So, in that sense, you would have it as labeled as a graph, where you have your graph. Let's mark -1 and then mark something similar for comparison, like 0. And you would say at -1, it's marked with an open circle, by the way, and everything above it would make this statement true. So that would include -1 would make this statement true, 0 would make this statement true, 1, 2, 3, 4, 5, and onward until infinity will all make this inequality true. That's basically what an inequality is. And this is what their graph looks like, this right here. All right, let's give another example. Let's say, actually, let's work on just graphing things, okay? Just graphing the example. So if I have x is greater than 4, x is less than or equal to 8, and x is less than -5, okay? So the corresponding graph for x is greater than 4, the way I think of it, you would just simply look at the sign on each one, right? And on the sign, we want to know which direction remember this cursor right here, this one right here? We want to know which arrow, which direction it's going, whether it's facing left or to the right. So we would take a number line, put 4 on it, and another number for reference, like I did before. You could do 2 numbers for reference if you like. I don't know what your teacher would specify, but whatever you do, follow their instructions. You mark 4 with a open dot. Open dot is specific. You want an open circle. And then see how it is like an arrow almost pointing to the right? Well, we want the exact same arrow pointing to the right. That is your answer. Let's do the same thing. We have 8 reference numbers, 7 and 9. This time it will be a solid dot going to the left because that is the way that the thing right here is facing. The symbol is facing. All right, and last but not least, we have -5. -5, we need a number for reference. -4 is right here, and -6 is right here. We put a open or close, should be open, and it's going this way. Now, when you have these up here, it will be make sure you either take a screenshot or whatever you need to do, but put this in your notes. Or whatever you need to do, put this in your notes. When there's a line underneath, that is a closed circle, and this is open. All right. Moving on. Let's see. For example, I'm doing number 10 on page 126 of the Check Yourself. This would be 4n minus 3 is less than or equal to 5. Add 3 to both sides, we get 4n is less than or equal to 8 divided by 4 on both sides. Now we have n is less than or equal to 2, okay? And then it gives us options where we have 2, comma, 3, comma, and negative 1. Now, let's read this in math and then make sense of it, okay? N is less than or equal to 2. So basically what it's saying is some quantity or number is less than or equal to 2. So what we do is we take each one of these and see if it is less than or equal to 2, okay? So, is 2 less than or equal to 2? Yes. Is 3 less than or equal to 2? No. Is negative 1 less than or equal to 2? It is less than, so yes. So, it says in the question, is each number a solution of the given inequality? 2 is, and negative 1 is. That is the answer to that question. All right, welcome to Chapter 3-2, Solving Inequalities Using Addition and Subtraction. This is quite simple. The last section was introducing, there we go. English was not my major. Introducing inequalities and their graph, yes? So now we will be doing basically 1-step, 2-step, and 3-step equations using addition and subtraction with inequalities. So, let's see. Example 1. If I have x minus 3 is less than 5, you simply add 3 to both sides like normal. And x is less than 8. Solution. Graph it like I showed you in the last section. Example 2. If I have 12 is less than or equal to x minus 5, add 5 to both sides. X is greater than or equal to 17. The way you always read it is from the variable to the constant. So you start here and then you end your way here. So another way you can rewrite it, of course, is simple. You have x and then face the thing the way I was taught is it's like an alligator. I can't draw an alligator. Let's see here. And a tail. Let's say that's an alligator. The alligator wants to eat the number or quantity or whatever that's bigger. You don't want to eat the smaller thing, right? So anyways, the point is you want to have the inequality facing the variable. This is the exact same thing as that. Okay? Moving on. If I have, let's do an example from the check yourself. If I have negative 2 is greater than or equal to 4 plus x. Subtract 4 on both sides. X is less than or equal to negative 6. Remember again, negative 2 minus negative 2, yes, minus 4 gives us negative 6. That's how I know that. Okay, so x is less than or equal to negative 6. Rewrite it in the x being first, and then face the inequality the exact same direction that it is facing in the previous inequality. And then you have your solution. And you can graph. You can't graph it when it's like this. No, but you can graph it when you're like that. Anyways, moving on to our last example. Let's say we have, let's do a hard one. Negative 6 is greater than n minus a fifth. Alrighty. Add a fifth to both sides. Alright, so now we have negative 6 plus a fifth is, let's see the inequality, greater than n. So we have to have the denominator the same as we always do. So we have 5. 6 times 5 gives us 30. Remember, this is negative. So now we're going to have a negative 30 over 5 plus a 1 over 5. We simplify this into being, if you get confused, what I want you to do is just cover up this part right here. Negative 30 plus 1 we know is negative 29. Now, bring back the denominator of 5. And then the inequality again. Bam, there's your answer. Moving on. Okay, here is chapter 3-3, solving inequalities using multiplication and division. Now, it is the exact same procedure when working with regular equations. Only thing now is when you multiply and divide by a negative, you will be flipping the direction of the inequality. For example, if we have a 12 minus x is less than 4, and then we subtract by 12, giving this canceling, negative x is less than, let's see, that would be negative 8. Now, we divide by not negative x, by negative 1. We now get x is greater than 8. This flips to the other side, okay? Let's say that again. This flips to the other side. Notice it was facing the right, now it is facing the left. When you divide by a negative, you are flipping the inequality sign. Just want to make sure that's clear. Okay, let's proceed. Graphing is the exact same. When you flip the when you flip the inequality sign, you will now be graphing that said direction. Okay, the new direction right here, not here. Okay. All right. Next example. If we have let's see, x over 2 less than negative 1 multiplied by 2 on both sides. Now we have x is less than negative 2. Final answer. Notice how the negative was already on this side. We didn't move it from here to here or here to here. It was already on the right side. Therefore, all we did was multiply by a positive 2, getting it to the negative 1. Therefore, it became a negative 2. The sign remains the same. Okay. New problem. If we have a x over 4 is greater than 1/2, this is a cross multiplication problem, okay? So we're going to multiply 4 to this side, and then I take that back. We don't need to cross multiply because it will simplify quite easily. All right, cool. Let's write it again. X over 4 is greater than 1 over 2. So first step, we will multiply 4 onto this side as well as this side. 4 over here is going to cancel. And over here, the 4 will cancel with the 2. The 4 will simplify to become a 2. And then the x will just become x is greater than 2. Okay? Another one. Let's do one from the check yourself. Let's say we have, here we go, negative 5 over 7. X is greater than negative 5. Multiplied by 7 on both sides, and then multiply by 7 on both sides. This cancels. The negative 5x is a greater than negative 35, but wait, we still need to get rid of this negative 5, right? So we divide by negative 5 on both sides. Now we divided by a negative 5. Hence, we need to switch this to face the opposite direction now. Negative 5 divided by negative 5 cancels out, leaving just x. Negative 35 divided by negative 35 bears just 7. This is your final answer. There we go. Alright, chapter 3-4 is solving multi-step inequalities. Basically, it's the same thing as solving multi-step equations, only we have introduced inequalities to it now. So, it's quite simple, like always. First example, let's begin. So let's say we have 7 plus 6x is greater than 19, okay? So, subtract 7, leaving us with 6x is greater than 12. And then we divide by 6 on both sides. Leaving us with x is greater than 2. Final answer. Next one. Let's say we have 6x. No, let's not do 6x. Let's do 2x plus 2 minus 3x is greater than or equal to negative 1. First, we want to distribute the 2 to the insides. So 2 times x gives us 2x, 2 times 2 gives us 4, minus 3x is greater than or equal to negative 1. 2x minus 3x gives us negative x, and 4 and the 4 and the negative 1 are terms in which we can subtract we can subtract this 4 to the other side, and it will give us negative x is greater than or equal to negative 5. Now we divide by negative 1 on both sides. This will flip the sign, the inequality sign, now giving us x is less than or equal to 5. Alrighty, on to another example. If we have, let's see, number 25. 2x minus 3 is less than or equal to 5x plus 9. Add 3 to both sides. 2x is less than or equal to 5x plus 12. Subtract 5x to the other side. Now we have negative 3x is less than or equal to 12. Divide by a negative 3. We divided by a negative 3, therefore the sign will flip. Bring down the x, and now we have x is greater than or equal to negative 4. Final answer. A review of graphing real quick. You have your number line, negative 4, negative 3 for relation purposes. And we do a solid dot, closed dot as I call it, going to the right. There you go. Alright, so now is when it starts, shifting up a notch. This is chapter 3-5, and this is called solving compound inequalities. Now, this section is kind of odd in that it will have 2 sets of inequality signs. So, for example, if I have 5, not 5. If I have 4x plus 3 is greater than negative 5, but on the other side I have let's do, I'm sorry, I can't think of a number. Let's do 1, okay? So what you do is, we have 1 is greater than 4x plus 3, which is greater than negative 5. So what we do is subtract 3 on all the sides. So we want to subtract 3 on all sides. 1 minus 3 gives us negative 2. Bring down the greater than sign. Bring down the 4x. We know this cancels. Bring down the greater than sign again. And then bring down negative 8. I guess lots of notifications want to go off in my house. Divide by 4 on both sides. This is perfectly okay. None of the signs will be switching because the 4 is positive. So now we know that this is going to be x, and we have this greater than and this greater than. Negative 8 divided by 4 gives us a negative 2, and negative 2 divided by 4 gives us a negative half. Therefore, this is our answer. Now, how exactly do we graph this, right? So, we will have our number line, and over here we'll have negative 2, and over here we'll have 0, just for comparison, right? Oh, wrong side, sorry. 0, and over here we'll have negative 2. Now, in the middle we'll have negative 1, and over here, right here, is where negative half is. Now, and just for relationship, or for reference, we have negative 3 over here, right? So to demonstrate where exactly this part is, you see how the x is between negative 2 and negative a half? So exactly, we're talking about between here, with open circles, of course. So this one, let me make that more open, here and here, and we're talking about the space in between, so all this. So that means we're not talking about negative 2, but we're talking about negative 1.9, which is right here, and negative 1.8, and 1.7, and 1.6, and negative 1 itself. And then we're talking about negative 0.9, negative 0.8, negative 0.7, negative 0.6, and of course negative half, which is negative 0.5. So all of those are within these boundaries between here and here. Let's do another one. If I have, okay, so that was a compound inequality in which we're referring to the graph in between. Now there is a certain thing in which we have a graph like this. You have a point here and here, but now we're not talking about this in between. We're talking about this over here and this over here. And it'll keep going on and on for this way and on and on for this way, but nowhere in between here. This is just a blank, deserted space that is not encompassed by the inequality, okay? So let's have, so the instructions say solve the compound inequality 4x plus 3 is less than negative 5, or negative 2x plus 7 is less than 1, okay? So what we do is we're going to take these parts, zoom out a little bit. We're going to do this one over here and this one over here. So over here we have 4x plus 3 is less than negative 5. Subtract 3 on this side. We have 4x is less than negative 8. Divide by 4 on both sides. We get x is less than negative 2. And then over here we get negative 2x plus 7 is less than 1. Subtract 7 on both sides. Negative 2x, this cancels, remember, less than negative 6. Now, we are dividing by a negative, so now we're going to divide by negative 2 on both sides. This will now flip. Now it's x is greater than positive 3. Okay, so now we have solved these two. Now it is time to graph them. So on our graph, we have here and here. Over here is 3, in the middle somewhere is 0, and then over here is negative 2, okay? So this will be negative 1, this will be 1, and this will be 2. 1 and 2. Okay? So we have, oh, and then this will be 4, and this will be negative 3. Okay, so let's choose something we haven't used yet. Let's use orange. So, excuse me. If we have 3, we notice that it is going to be a open circle, and it is pointing to the right. Therefore, we're talking about all this over here. If we look here, it is also going to be an open circle, where at negative 2, open circle, and it's pointing to the left, so we're talking about all this over here. So only space we are not talking about is this in the middle, which will be in between -2 and 3. And the way you would write this, how would you write this? You wouldn't write it together. You would write it separately. You would write it like this or like that. Can I put it together? I think I can. Yes. No, because then that would be conjoined. No. Never mind. We don't want to put it together. That would be more confusing in mathematical terms. Anyways, on to the next section. All right, this is the last section of chapter 3. This is called absolute value, equations, and inequalities. Now, real quick review of what absolute value is. That is example. The example would be if we have -5, we have absolute value signs that look like that. It now becomes 5. All it does is get rid of the negative sign. If you have a -3 in absolute value, it becomes 3. If you have -20 billion, it now becomes, positive 20 billion. Perfect. All right, does that make sense? Hopefully it does. Going on to the problems. So if I have 3 minus 7 in absolute value sign, normally 3 minus 7 would bear -4, yes? But the absolute value signs are around it. Therefore, the absolute value of -4 is just 4, okay? Now, that is an equation. We are talking about inequalities. So let's do a few more examples of equations, and then we'll do a couple inequalities, okay? So if I have the absolute value of x plus 5 is equal to 11, what I do is I subtract 5 on both sides, leaving me with absolute value of x is equal to 6. Now, being that the absolute value of x, new word for you, the word is domain. The absolute value of x has 2 possible inputs or domains and only bears 1 output. We know that, basically, let me put it in simple terms. 2 things can go in here to give you 6. You can have positive 6 or negative 6. The fact that we don't know which one it is says that we are going to put down both, 6 or -6. Those are our answers, okay? Let's do another one. If we have absolute value of x minus 4 equals 12, add 4 to both sides. Absolute value of x is equal to 16. Now, once again, we don't know if it's going to be positive 16 or negative 16. That was originally in the x. So what we're going to do is just put both, 16 or negative 16. And these are our final answers. All right, done with equations. Let's do a more complicated one, though. I like that one. Okay. If we have 2x plus 5 is equal to 11, but these are in absolute value signs, what we're going to do is, basically this tells us that there can be 2 possible equations, okay? So that means that 2x plus 5 equals a positive 11, and it also means that 2x plus 5 can also equal, take that back, equal negative 11. We don't need the absolute value signs because that's what we just split this up into. Okay? Now, we know how to solve each of these quite simply. Subtract 5 on both sides. We have 2x equaling 6. Divided by 2, x equals 3. On this side, subtract 5. This gives us negative 16 equaling 2x divided by 2. X equals negative 8. And this one, x equals 3. So, and of course you would separate it by or, okay? So the value of x would be 3 or negative 8, because I'm going to prove it to you real quick. If we have 2x plus 5 equaling 11, the absolute value, of course, let's plug 3 in. Let's say we have 2 times 3 gives us 6. plus 5. The absolute value of 6 plus 5 is 11. The absolute value of 11 is 11. That just looks like 4 lines equaling 2 lines, huh? It's funny. Anyway, the absolute value of 11 equals 11. Also, if I plug in 2 and a negative 8, right? 2 times negative 8 gives us negative 16 plus 5. Negative 16 plus 5 gives us negative 11, and the absolute value of negative 11 just gives us 11. Either way, you get the same 11, but we need to be able to make the statement true. If you don't have 1, the statement is only half true. We want the entire truth, okay? Now, done with equations for sure this time. Now let's do inequalities. If I go back to red, and I don't like this orange, blue, and I don't like this green either, pink, purplish, whatever. If I have x minus 3, absolute value sign, is greater than or equal to 4, what I'm going to do is I'm going to break this up into 2 equations, inequality, excuse me. X minus 3 is greater than 4, and x minus 3 is less than, notice we flipped the sign, less than or equal to negative 4. So the one that we switched the sign for, that's going to be the negative, the negative 4. So add 4 to both sides like normal. I'm sorry, add 3 to both sides. And then we get x is greater than or equal to 7, as well as add 3 to both sides, we get x is less than or equal to negative 1. Plug both into your original inequality up here, and you will see that I am accurate. Where's my tongue today? 7 minus 3 gives us absolute value of 4 equaling just 4, and negative 1 minus 3 gives us negative 4. Absolute value of negative 4 is just 4. Either way, you get 4. And of course, you know how to graph both this and this. I don't need how to show you, but just in case you forgot, you have your number line. Negative 1 is there, 0 is here, and then 7 is here. 7 is there. At 7, it's pointing outward with a closed dot going that way, and negative 1 is with a closed dot going this way. So any number in this area will make this statement true, and any number in this area will also make that statement true. Cool beans? Cool beans.